This section is called variation, and variation means various types of proportions. And so it takes the notion of simple proportions, which all of us relate to very well, and extends it into different dimensionality, so to speak, or different kinds of relationships. Anyway, some of you may have studied this in an earlier algebra class. We always covered it in college algebra. I like to introduce variation with my pizza problem that I wrote about in my book, but I'll introduce it here with something different. So here's a question I'll pose to you. A 5-foot tall tree weighs 20 pounds. What would a similar 10-foot tree weigh? So what's your immediate answer? It's going to be what? 40 pounds? Not likely. Not likely. You think, well, okay, this tree is twice as tall as that one. Shouldn't it weigh twice as much? Well, what if you had a similar tree that was 100 feet tall? Think how big a 100-foot tree would be. You know, they're enormous, very big, very thick, very heavy. A 100-foot tree would be 20 times as tall as a little 5-foot tree. And if it weighed 20 times as much, then a 100-foot tree would weigh about 400 pounds. That means, a couple of guys could just, pick one up and put it on their shoulder and carry it out. And that's, when you think about it in those terms, you think, well, that's absurd. A 100-foot tree must weigh a lot more than 400 pounds. Give you a kind of a similar example. My youngest daughter, when she was born, she was 20 inches long and weighed 7.5 pounds. And by the time she reached 5 foot tall, and 5 feet is about, 5 feet is 60 inches, so that means she was 3 times as long or tall as when she was born. Went from 20 to 60, it's 3 times as long. But she didn't weigh 3 times as much. If she had, she would have weighed 3 times 7.5 pounds is something like 22.5 pounds. No one 5 feet tall weighs 22.5 pounds and lives for very long. Actually, she weighed around 100 pounds. So something different going on there. That these are not simple proportions. By the way, the problem with my daughter is a little more complicated than what will look like with the tree problem, because one thing about infants, when infants grow, they change shape. When you're a newborn, your head goes from about here down to here, and we got these little pot bellies and short stubby arms. And then when you grow, you tend to thin out. Your head, it doesn't grow as fast as the rest of your body. We change shape, and so that also alters the mathematics of this. But what I really want to point out here is not as simple as saying in this problem, twice as tall means it's going to weigh twice as much. Actually, you would expect a 10-foot tree, if this is the case, a similar 10-foot tree would weigh 160 pounds. That would be the prediction. It would be 8 times as much. And where am I getting 8? Well, when the tree grows, it doesn't just grow in height. It grows in width and depth. So it grows in 3 dimensions. And what is weight based on? Weight is based upon 3 dimensions. And so you think, well, okay, if it's twice as tall, it's twice as wide, twice as deep. 2 times 2 times 2, it means 8 times the volume, or 8 times the weight. So a 10-foot tree would weigh about 8 times 20, roughly 160 pounds. And a 100-foot tree, let's see, that would be 20 times 20 times 20 is 8,000. 8,000 times another 20 would be about 160,000 pounds. So you would expect a 100-foot tree to weigh closer to 160,000 pounds, which would be about 80 tons. So, and that's, I suppose they do. I don't know. But the supposition here is similar, means same proportions, same shape. And that's an important assumption if we're going to apply this mathematics. All right, well, I want to show you how this translates And incidentally, if you haven't read my pizza problem in my book, you should read that also, because that's another neat problem of this nature. And anyway, let me introduce the language of variation. And I'm going to erase the board and rewrite this problem in a way that you might see in a textbook. I've rewritten the problem. The weight of a tree varies directly to the cube of its height. A 5-foot tree weighs 20 pounds. What would a similar 10-foot tall tree weigh? So I've worded this in a way that might appear, in your textbook or in my book or on a test, that sort of thing. In a math class like this, the physics is already done for you. And the physics is the relationship expressed in the first sentence. The weight of a tree varies directly to the cube of its height. And so, and I explained, a minute ago what, roughly, basically where they came from, because as a tree grows, it grows in height and width and depth, and so it grows proportionally to the volume, and basically according to the third power of its height is the way it works out to be. All right, so all that physics type of observations, those or science observations, will be given to you in these problems. And so there really are three big steps to these problems. The first one is translating the relationship, the variational relationship. We translate that into a prototype equation. And then we have to solve for a number in that equation. And that's done with this piece of information in this problem. A 5-foot tree weighs 20 pounds. That allows us to solve for a particular number. And then a third part is to apply it to something else. And so I'm going to walk you through these steps and let's point out some key words here. All right, the weight of a tree. And I'm going to call that W. So let me see, weight is W. It varies directly. Now, varies directly is an important phrase. There are a couple of those phrases in this section. There's varies directly, varies inversely, varies jointly. And so we'll work examples of all those. But a direct variation is one in which you're comparing two quantities, and when one increases, the other one increases, or vice versa. So, in this case, taller trees weigh more. Shorter trees weigh less. So a direct relationship, those increase or decrease together, and you're only comparing two quantities. So it varies directly to the cube of its height. And so cube of the height would be h to the third power. Now here's where people screw up a lot. They read these fast, they don't read carefully, and they overlook key words like varies directly or cube. Cube means what? It means third power. If it said cube root, that would be cube root, but cube means third power.